Greetings to Madam Shwada. I'm Khiirtaana Arunasalam with matrix number 33DCE20F2011 from DCE2A. Today I would like to present my practical task 4, which is Brinell Hardness test for material science and engineering. So what is Brinell Hardness test? Brinell Hardness test is a non-destructive testing technique which determines the hardness of metals by measuring the size of an indentation left by an inductor. The objective of this experiment is to determine the indentation hardness of mild steel, cast iron, brass and aluminium using Brinell hardness testing machine. The apparatus used in conducting this experiment is Brinell hardness testing machine. Step 1. Select the load P based on the type of material selected. First, I choose cast iron. So the load would be 3000 kg. So the diameter of the indenter D is 10 mm. D remains constant until the final of the experiment. Each weight is equivalent to 250 kg. Supporting hanging rod and base plate is 250 kg. Step 2. The specimen is placed on the supporting table. Then the hand wheel below the table is turned in clockwise direction until the gap between the surface of the specimen and the inductor is 5 mm. Step 3. The motor is switched on. The hand level is pulled into load position. The load is applied for a period of 10 to 15 seconds. Step 4. The hand level is pulled back into unload position. The diameter of the impression is measured through a microscope attached to the apparatus. So this will be the observation for trial 1. The Brinell hardness test number would be calculated using this formula. So next is for trial 2. Step 2 until 5 is repeated. The measured diameter is 5.9. So this would be the observation. So this would be the observation for trial number 1 and trial number 2. So for the second one, I choose mild steel. The load of mild steel is 3000 kg. So step 2 until 5 is repeated using mild steel. The measured diameter is 4.67 for trial 1. So this would be the observation for trial 1. Step 2 until 5 is repeated also for trial 2 using cast iron. The measured diameter for trial 2 is 6. This would be the observation, and this would be the overall observation for trial number 1 and trial number 2 for mild steel. Next, we use the brass material. So the load for brass is 1000 kg. Step 2 until step 5 is repeated for trial 1. The measured diameter for trial 1 is 3.41. So this would be the observation for trial 1, brass. Next is for trial 2. This is the observation for trial 2, and this is the observation for overall experiment for brass, which is trial 1 and trial 2. Last experiment is for aluminium. So the load for aluminium is 500 kg. Step 2 until 5 is repeated for trial 1. The measured diameter is 2.81 for trial 1. So this is the observation for aluminium trial 1. So for trial 2, the measured diameter is 2.6. This is the observation for trial 2, and this is the overall observation for aluminium. In the end of this experiment, we can conclude that mild steel is the hardest among cast iron, brass and aluminium. It also showed aluminium as the softest specimen among the metals used. Mild steel hard than aluminium because mainly due to the high concentration of carbon. The more carbon contains, the heavier it will be due to its high density and weight. It is less likely to bend under the force. However, there are some percentage of error between the experimental value and theoretical value.